So just like with chapter 9, we're going to start off chapter 10 here learning about alcohols by naming. So we're going to learn about how to name alcohols and then how to do syntheses with them. So with an alcohol, kind of similar to what we've seen with alkanes, alkenes, and alkynes, the final portion of that name, right, how alkanes are ane, enes are ene, alkynes are ine, we replace that last portion with an OL, right? So instead of it being an alkane, it would be an alkanol, and so forth. And when OHs are present in a carbon, that backbone containing the OH must be the parent chain. So OHs basically take total priority, and including with numbering, right? If an OH is present somewhere in the molecule, it has to take priority over any other groups. So let's take a look at what we mean by that. So looking at this first example here, right over on the left, right, we see we have this alcohol present. So we would number it like this, with the OH being 1, chloro being 2, and then going around the ring like so. And if we were going to put this name together, we would do it like this. We would say 2-chloro, cyclopentanol. Okay, and because, right, just like with cycloalkane naming, because alcohol is in the number 1 position, we don't need to denote that. We could if we wanted to, right? It wouldn't be wrong to do that. It's just sort of excess information. We would say 1-all, just like we did with the alkynes and alkenes. So over here, with this alkyne, or the alkyne should be linear, but it's not drawn here. However, right, for numbering it, even though, right, the alkyne would be in the 2 position, if we numbered it from left to right, remember, we need to make sure that the carbon with the OH must take priority in the backbone. So we know that's not correct. So we actually have to number it this way. So whenever you see an OH, that should be your main focus in naming. It just takes priority. And again, there's nothing scientific about that. That's just kind of the way the IUPAC rules work for naming. So if we were to put this together, right, we see that in the 6th position, we have that ine. In the 3 position, we have that alcohol. And then we have oct as our parent chain. So stringing all of this together, we would say oct 6-ine, right, not having the E at the end, of course, 3-all. So oct 6-ine 3-all would be the full name for this. And some other pieces of naming, just to kind of point out here, is similar with talking about alkyl halides. We can talk about alcohols in a similar way. We have primary alcohols where we have an alcohol attached to a carbon with only 1 other carbon attached to it. Secondary alcohols, right, with only 2 carbons attached, and then tertiary alcohols when there are 3 carbons attached to a carbon-oxygen bond. So one other thing we can do for naming is we can start looking at aromatic groups as well. So let's look at some examples of when we have something called a phenol. And so a phenol, right, comes from, right, the 2 different parts of its name, phenyl, right, which is that benzene ring, and then all, of course, meaning the alcohol. All right. And so when we are naming these things, there is this sort of special connection between aromatic rings that we can look at as well. So when we have 2 different groups, or you can see this down below, that are right next to each other, we call this ortho. Right, these 2 groups are ortho to each other. We would call groups meta to each other when they are 3 positions away. And then finally we call groups para when they are 4 positions away, right? They're opposite each other on a benzene ring. And this sort of naming will come up later when we get to the aromatic ring chapter. But they do have some relevance to us now talking about phenols. So if we were to generate a name for a phenol, what would that look like? Right, so we have an alcohol, we have a methyl group. How would we name this? Right, so just like before with that cyclopentane ring, we can number it like so, where we have, right, 1, right, we want that alcohol to be our priority in any situation, and then our methyl group would be 2, and then we count around the ring, like so. And so if we were to put this name together, we would have 2-methyl phenol. And again, right, we don't need to denote 1 for the phenol because it's assumed that we're starting at the 1 position, okay? Another way we can name this now, right, because alcohol and methyl group, they're ortho to each other. So we can also say O, right, for ortho, O-methylphenol, like so. And so in class, we'll go ahead and look at some other examples for naming here, using this ortho-meta-para designation. And we'll look at some examples of regular alcohols as well, and not just phenols.